I'd like to talk now about reduction. This is another way that we can form alcohols. And before we do that, let's talk about what reduction and oxidation actually are. Now, reduction in organic chemistry can be defined as being the loss of oxygen and or gain of hydrogen, while oxidation can be defined as being the gain of oxygen and or loss of hydrogen. Now, when you're looking at reduction, a good sign that reduction is occurring is that we see a decrease in bond order. So we go from triple bonds to double bonds to single bonds. That's a sign that reduction is occurring. The reverse process, going from single bonds to double bonds to triple bonds, is a sign that oxidation is occurring. And this is a good thing to remember because it's a good way to tell whether oxidation or reduction is occurring in an organic system. In our particular process though, what we're doing is we're taking a C double bond O and converting it into an OH and a CH. So we're effectively adding two hydrogens to the C double bond O. And this is clearly a sign of reduction. Alright, let's look at our reduction reaction. We're using sodium borohydride as our reducing agent. Let's take a look at what that looks like. This is sodium borohydride, boron with 4 hydrogens bonded to it. Taking a look at where boron is on the periodic chart, you'll notice that it is close to being metallic. It's a non-metal, but it is close to the metals. It's called a metalloid or a semi-metallic compound. As such, what we can do is we can actually say that the boron is less electronegative than the hydrogen is. As such, being metallic, we can draw a delta plus on the B, and that means we can draw a delta minus on the H. And all these H's can have delta minuses on them. Now, when I'm looking at sodium borohydride, the only thing I'm thinking about is H negative, and that's what I want you to think about too. The H negative being as a result of the higher electronegativity of hydrogen relative to boron in the sodium borohydride. I'm not really interested in the rest of the molecule, just the H minus, and that is going to be our reducing agent. Alright, let's take a look at our reaction. And we'll take a good look at what's going on with the mechanism as well. Alright. So we've got the H minus, and what's going to happen is it's going to come in and attack this carbon, which can have a delta plus drawn on it. And the reason for that is because the oxygen is delta minus due to its great electronegativity, and the C attached to it then will be delta plus. This C double bond O is known as a polar bond because of the difference in electronegativity between these two. A double bond seems to make that even greater. So what's going to happen is the H negative will naturally be attracted to this partially positively charged carbon atom. Now, when I'm drawing these, I don't have to show the delta pluses and the delta minuses. I'm just showing you those so that you can get an appreciation for why the H minus might be attracted there. Alright, so what we're trying to show is a bond will be created between the H and this C. Now keep in mind, if I just bond the H to that C, I'm going to end up with 5 bonds on that carbon atom. So I have no choice but to push 2 electrons out of the double bond and onto the oxygen. And that's what this arrow is showing, that 2 electrons from this double bond will go onto the O. And effectively the negative charge from the H gets transferred to the oxygen. There we go, here's our new bond between the H and the C, and the negative charge is now on the oxygen. Now I want you to look at over here at the way that the steps are laid out as well. It says number 1 NaBH4, then number 2 H+. What that means is I have to use the NaBH4 first before I use the H+. I can't put these in together into the reaction mixture. If I did that, I would end up getting a reaction between H- and H+. So what I'm talking about is this. Let's say we didn't have those numbers on there. It would be NaBH4 and H+, and we'd be throwing those in together, but if we did that, these two would react, and we'd get H- plus H+ would give H2 gas, which would give an explosion. Alright, so we don't want to do that. What we want to do is say that we want to put the sodium borohydride in first, and then we want to do the H+ second. Alright, so let's go ahead and do the H+. And the way we'll express that is we want to form a bond between the O and the H. Now remember, the arrow has to come from the place where the negative charge is, or where the electrons are coming from, and that's going to be this oxygen. And then the arrow goes towards the H+. And there's our final product. Now keep in mind, I use the H- first, and then I use the H+ second, and I did that because the reaction told me to. I put number 1 H-, number 2 H+. Number 1 H-, number 2 H+.